Hello and welcome. Today we will talk about arithmetic progressions and some interesting new ways of looking at them. You are probably familiar with these standard symbols and formulas for arithmetic progressions, or APs, so we will go directly to the more interesting part. First point, start anywhere. If you have a series of numbers separated by the same common difference, you can form an AP by choosing any starting point as the first term. Let us take a look at an example. Here we have an AP with 100th term 20 and common difference 3. We have to find the sum of terms from the 101st to the 110th. The standard method is to plug in standard formulas, find the first term, work out S110 and S100, then subtract. This is quite a bit of work, as you can see here. Instead of doing that, let us define a new AP, where the original 101st term is the new first term. This is 20 plus 3 equals 23. Now we just have to find the sum of the first 10 terms. Applying the standard formula gives the answer of 365. Note that we don't really have to work out the original first term in order to work out the solution, and that saves us quite a bit of work. Second point, big steps. Every kth term in an AP forms another AP, where k times d is the new common difference. Now consider an example. An AP has first term 1 and common difference 4. Find the sum of all even terms up to the 100th term. So here k equals 2, i.e. we want to consider only every second term. Note that all the terms we are interested in form an AP themselves. This is shown in yellow. The new AP has a common difference twice the value of the original, i.e. 8. In this new AP, the first term is the second term of the old AP, i.e. 5. Also, there are only 50 terms. Applying the standard AP formula gives the sum of these terms as 10,050, which is the answer required. Third point, centerpiece. If we are given the central term and the total number of terms in an AP, we can determine the sum of that AP immediately, without any further information. Let us see example 1. Here we have two different APs, with the same central term of 6, and the same number of terms, which is 5. We can easily see that the sums of both APs are equal, which is the product of the central term and the number of terms, i.e. 5 times 6, which is 30. We do not really need to know the first term or common difference. In example 2, we have an AP with 1001 terms, and we are told its 501st term is 2020. This is the central term because 500 plus 1 plus 500 equals 1001. We want to find the sum of the AP. Using what we learned earlier, the sum of the AP is n times i.e. 1001 times 2020, which is 203,010. If we use the standard method, trying to first work out the first term and common difference before calculating the sum, we find that this leads us nowhere. This is because the first term and common difference are indeterminate here. They can take any value as long as the central term is 2020 and there are 1001 terms. So this illustrates the usefulness of the method discussed. Now, why does this work, you might ask? To answer this, let's look at the standard formula for the sum to n terms, Sn equals n over 2 into 2, a plus n minus 1 into d. Rearranging this a little results in n on the outside, and an expression which looks like um or the mth term on the inside of the parenthesis, where m equals n plus 1 over 2. Hence Sn equals n times um. What is interesting is that this method works even if the central term doesn't exist. This is the case if the AP has an even number of terms. For example, if there are 10 terms, where the fifth term is 31 and the sixth term is 41, the virtual middle term is in position 5.5. The value of this middle term is the average of the fifth and sixth terms, which is 36. Since there are 10 terms, the sum is 10 times 36 equals 360. If the central term is not given, it can sometimes be worked out easily from the information provided. One example is where two terms are provided which are positioned symmetrically about the central term. For instance, if an AP has 9 terms, the central term is the fifth term. The value of this term is the average of the fourth and sixth terms. It is also the average of the third and seventh terms, as in the example shown. This average is 60, so the sum of the 9 terms is 540. Fourth point, count backwards. An AP viewed backwards is another AP, but with a common difference which is negative of the original one. In the example given, the AP has 1 million terms, with last term 2020 and common difference 0.2. To find the sum of the last 100 terms, we just turn the AP backwards starting from 2020 as the first term, with a common difference of minus 0.2. Applying the sum formula for 100 terms gives 201,010, which is the answer required. We have gone through some new ways of looking at arithmetic progressions. Using some of these methods, we can sometimes simplify the process of solving AP problems. Please note that these are non-textbook methods, so please do not use them in exams. However, they might be useful in checking the answers you have worked out using standard methods. We hope you have found this video interesting. If so, please like and subscribe. Thanks for watching.